Breaking news! Mercury is getting smaller. Well, we used to think that our planet was the only one in the solar system that had tectonic activities, meaning that the planet releases heat because plates under the crust move, which changes the surface and eventually makes the planet smaller. But it happens on Mercury too. Researchers took pictures of the planet back in 2016. These pictures showed landforms that were reminiscent of cliffs. They're called fault scarps. Since they are relatively small, the team believes they were formed not very long ago, which means Mercury is still contracting, even 4.5 billion years after the solar system formed. Mercury has a solid inner core, and there's a liquid metal outer core that surrounds it. It's still going through a cooling process. In fact, all rocky planets are still cooling from the times when they were initially formed. As those liquid parts of the planet's core become more solid, the planet contracts and becomes smaller. How come you don't see planets twinkling like stars? If you were up in space, you wouldn't see stars twinkling. But on Earth, you see it because of the atmosphere. Our protective blanket of air refracts the light of stars, which means it scatters it in a zigzag pattern. We perceive this as the twinkle. Planets appear way bigger than just pinpoints. Their light also zigs and zags after hitting the Earth's atmosphere, but these motions kinda cancel each other out, which is why we see their steady light. Now, if you brought a block of lead on Venus, it would melt like a block of ice on our home planet. The surface temperature on Venus goes up to 900 degrees Fahrenheit. Even when researchers send spacecraft up there, it can't withstand the environment for too long. One craft, for instance, landed there in 1982 and managed to stay for only 2 hours. But a team still got the first color pictures of Venus and analyzed some of the planet's soil. Planets collide with asteroids, comets, other planets, and the rest of the celestial bodies that move through space. But galaxies also collide. Milky Way, our galaxy, is about 2.5 million light-years away from Andromeda, our closest galaxy neighbor. They are getting closer and speeding toward each other at 250,000 miles per hour. It's inevitable. One day they'll collide and everything will change. Two galaxies will merge into one brand new, unique one. And some planets and stars won't survive. But, according to predictions, this won't happen for another 4 billion years. Plenty of time to, well, do most anything. The combination of the gravity on our planet and the gravitational force of the moon leads to changes in ocean tides. So, when you jump, you're pulled back to the land because of the invisible force that pulls things toward each other called fill in the blank. Gravity. Good for you. The moon has about 80 times smaller mass than the Earth, but it still has a gravitational pull. As our planet rotates, the moon's gravitational pull influences the closest part of the Earth. It affects the whole planet, not just the water. But the land is denser than the water, which is why we see the effects of the moon's gravity on the water only. And the results are the tides. On the opposite side of our planet, the one that's farthest from the moon and where the moon's gravity is the weakest, the tide is high because the moon pulls the rest of the Earth towards itself, away from us. What do you think space smells like? Well, you can't actually smell it because your nose doesn't work in a vacuum. But astronauts that work aboard the ISS have said they've noticed a specific metallic aroma on the surface of their spacesuits after repressurizing the airlock. They compared it to the odor of welding fumes. Other things in space have a specific smell too. For instance, there's a lot of hydrogen sulfide in the atmosphere of Uranus, which smells like rotten eggs. Venus and Mars have a similar odor. The atmosphere on Mercury is quite sparse, which means it doesn't have much of a smell. On Jupiter, it depends where you are in the atmosphere. Some parts have high levels of ammonia, so you'd smell something like cleaning fluid. Other parts have an egg-like smell, but the rest, the parts with high levels of hydrogen cyanide, smells like bitter almonds. And you don't want to take a big whiff of that, trust me. Here on our planet, when you try to fuse two metal bits together, you have to apply enough heat that the metal gets to its melting point. It's way simpler up in space. You don't need heat or any action at all to stick two pieces of metal together forever. It's something we know as cold welding. It happens when the metal bits slide over each other. They have protective oxide layers. On the Earth, that's something that stops them from fusing. But in space, this type of protection is gone. So the electrons from one metal piece simply flow into the other one and they become one. There are rocks from space all over the Earth. In 1996, a geologist found a rock in the Sahara Desert. After studying its composition, scientists realized they hadn't seen anything like it before, even on other planets or with other meteorites. One theory says this stone was even older than our solar system. It had a specific combination of elements that was probably characteristic of early solar nebula. Pluto was demoted from a planet to a dwarf planet, partially because of another dwarf planet called Eris. Eris was found in 2005. It has a similar size as Pluto, so astronomers were worried that the number of space bodies that orbit the Sun and that are waiting to be discovered might have been compromised when it comes to being an official planet. So, after they discovered Eris, they set up new standards for a celestial body to be called a planet. Round, orbit the Sun, and orbit clear of small objects are just some of the criteria for a celestial body to be considered as a planet. And you have to score well on the SAT. There are more than 20,000 pieces of space junk that humans created, circling around our planet. And these are just the pieces that are larger than a softball, while the real number of total pieces our researchers track is way bigger, somewhere around 500,000. There are millions of bits so small we can't even track them. In space, junk can move at high speeds, sometimes more than 17,500 miles per hour. That means even small objects, like a chip of paint, can damage an operational spacecraft. So the International Space Station has to carefully maneuver itself to avoid space junk. And there's another potential problem there. It's called Kessler syndrome. When there's so much junk in low orbit of our planet, it smashes together, which leads to more and more debris, like some sort of space domino effect. One of the potential ways to solve this is by using nets that would push the objects into our atmosphere, and then we could clean up at least some of the space junk. Neptune has a pretty interesting moon called Triton. It kind of reminds us of Pluto because of its similar composition, but it's also in retrograde orbit. Triton is probably one of the icy objects in the Kuiper Belt. Neptune's gravity probably trapped it at some point and turned it into its own moon because Triton has been orbiting Neptune ever since, and it's been doing it in the opposite direction that Neptune is rotating. One of Triton's coolest features is its erupting geysers. There's water on two of Saturn's moons. The first one, Enceladus, has a whole ocean made up of salt water. And based on some complex organic molecules, there could even be a sign there's some form of life. But this is just a theory that no one can yet confirm. Titan, the other moon, could also have signs of life. Any place in space that has both carbon-containing chemicals and water is a potential home for some form of living organism. What's the coldest planet in our solar system? Your first thought is probably Neptune, since it's the farthest planet from the Sun. But it's actually Uranus. It's 20 times further away from the Sun than we are. The average temperature at its cloud tops, and that's what we call the surface temperature in gas giants since they don't have a solid surface, is minus 315 degrees Fahrenheit. Enough to give you a bad case of freezer burn. Planets that are so far away from our Sun can't get much heat, which is why some heat comes from their core, similar to how the core of our planet is hotter than the surface. But it's not enough, so both Neptune and Uranus are cold. But Neptune has methane in its atmosphere. On Earth, methane is a greenhouse gas, which means it traps heat like a thick jacket that keeps you warm. And Uranus has less methane in its atmosphere, which is why it's a bit colder than Neptune, even though Neptune is farther. Speaking of Uranus, did you know a season there lasts for one pretty long day? Yup, that one day is equal to 42 years. The planet makes a single circle on its axis in 17 hours, but its tilt is so pronounced that one or the other pole is mostly directed towards the Sun. This means that a day on the planet's north pole lasts 42 Earth years, which is half of a Uranian year. So if you could go to Uranus and stand on its north pole, you'd see the sunrise in the sky. You'd circle around for the entire summer, after which you'd face 42 years of darkness and winter. No thanks, I'll stay here. There are a lot of space objects all around the universe, from stars to planets to satellites, comets, and asteroids. But our closest celestial body is the Moon, which has been subject to much research, theories, and even myths. As our only natural and permanent satellite, the Moon is in the top 10 list of biggest satellites in our solar system. It's located in an outer spiral arm of the Milky Way galaxy. Other planets in our solar system, like Mars or Jupiter, have many other moons. Saturn is the planet that tops this list, with an astonishing 82 moons, of which 53 have names. Shall I go through that list of names? No? Okay, we'll move on. Our moon, with its mean radius of 1,079 miles, isn't the biggest moon in the solar system, but is the largest compared to the size of the planet it orbits. The difference between a satellite, like the Moon, and a planet isn't their size, although that might be your first thought. The largest moons in our solar system are really huge. Some of them are even bigger than planets. Jupiter actually has a bunch of these types of satellites, like the icy Ganymede. It's the largest moon in our solar system, larger than Mercury and Pluto. It may even have an underground saltwater ocean that can surpass all the water on Earth's surface. Our moon's diameter is a bit larger than a quarter of that of the Earth. When it comes to mass, though, it's 80 times less than our Earth's. To paint you a better picture, if you think about our planet as being a big hollow balloon, you would need about 50 moons to fill it. But let's look at our moon's size from a bit of a different perspective. How does it compare to the United States? Well, the U.S. measures 2,800 miles wide horizontally, which means the moon is smaller in diameter. It's difficult for us to see it any other way, but what if our satellite was twice as big? Well, first, we would see way more of those solar eclipses. In present conditions, they can happen 2 to 5 times a year, and 5 times is more of an exception. The last time there were 5 solar eclipses in a year was back in 1935. You'll have to wait until 2206 to see the next event like this. I might be around for that. If the Sun and the Moon look about the same size from down here on Earth, but I guess it won't be a surprise if I tell you the star we're orbiting around is enormous. So if the Sun was hollow, how many moons do you think you'd need to fill it up? Wait, no need to Google. You would need 64.3 million Earth moons, or about 1.3 million Earths. Yep, it's that huge. And while we're on the subject of our Sun, it has a diameter of 864,000 miles. Its mass? Well, it's no less than 330,000 times bigger than that of the Earth. What is a star, though? I'm not a scientist here, so I'll try to keep it simple. It's a ball of bright, flaming hot matter held together by gravity. The reason why they give off both heat and light is that, well, they are very hot. Experts call the smallest stars red dwarfs because of their size and color. They're also the most frequent types of stars in our galaxy, with some of them being so tiny and dim they are invisible to people on Earth. It's the case of our nearest neighbor star, Proxima Centauri. Our Sun is considered a medium star since it has an average mass, brightness, and life expectancy. There are also giant stars out there. They are rarer but easier to see. That's why you can safely assume that roughly every star you see after the Sun is set is much larger than the Sun. But enough about it. Let's bring it back to the star of today's show, the Moon, our only natural satellite. But is it? That may or may not be the full truth, actually. Back in 1997, a group of scientists stumbled upon an asteroid about 3 miles wide, looking like it was caught in Earth's gravitational grip. It looked like a satellite of our planet. They called it Crunia. It takes this guy about 770 years to make a trip around the Earth. It also seems that it will remain in a suspended state around our planet for at least another 5,000 years. The Moon is also kind of steering away from us. With each year, it essentially holds up some of our planet's rotational energy and uses it to launch itself about 1.5 inches higher in its own orbit. If the data we have available today is correct, back when it was born, our Moon was about 14,000 miles away from us. The distance now is 239,000 miles on average. So, what will happen when it moves away completely? Well, no more songs like Moon River, Fly Me to the Moon, How High the Moon, that's for sure. Then, there will simply be no tides in our planet's oceans, and our nights would become darker. The seasons would look a lot different, and so will the lengths of our days. Based on current calculations in the science world, this will take about 50 billion years or so. So, there's no need to rush out stocking up on flashlights just yet. Unless you just like to hoard stuff. There's also another catch here. Our sun gets about 10% brighter every billion years. I'll spare you the calculations, but to sum up, it's more likely that long before the Earth will be left without its moon, the sun will have already swallowed them both. Gee, I don't find that any more comforting. But hey, what makes a planet, well, a planet, and why isn't our moon considered one? I mean, it's bigger than some other objects in our solar system, which are technically planets. For starters, a planet is a celestial body that does three things. It orbits around a star, not something else. It is massive enough to become roundly shaped because of its own gravity. And lastly, it has the power to snatch up any dust or fragments in its orbit as it continues to move around the sun. So, we've established that the moon doesn't orbit the sun, but it doesn't really orbit the Earth either. Both of them orbit a certain point stationed between them called the barycenter. It's about 1,000 miles below the surface of Earth, sure, but still some 3,000 miles from the center of our planet. Since this barycenter lies beneath the surface of Earth, we do not consider the moon a planet. To be able to do so, the moon would have to be either about a third larger or a third further away, so that the barycenter would be independent of Earth's surface. The moon does have some other planet-like characteristics, though, which makes it very special in our solar system. Firstly, it has a crust, a mantle, and a core. It also has quite an active geology, with events like our own earthquakes. You guessed it right, they're called moonquakes up there. Hey, do they have moon pies up there too? Nah, come on. Let's continue our space exploration a bit more. Wait, what? You can't hear me? Of course you can't, because space is utterly silent. Since there's no atmosphere in space, sound has no medium or way to travel for you to hear it. You will want to steer clear of Venus if you do wish to continue your outer space travels. It's the hottest planet in our solar system. It has an average surface temperature of around 840 degrees Fahrenheit. Hot! You'd think that's because it's closest to the sun, but it's not the case. You would also think that the closest planet, Mercury, would then be the hottest. Well, since this one has no atmosphere that would help regulate the temperature, it tends to have bigger fluctuations. Your calendar would also be very messed up on Venus, since one day on its surface is about as long as a year on Earth. That's because Venus is rotating slowly around its axis, taking 243 Earth days to complete its own day. If you were to pit stop on Mars, be on the lookout for those blue sunsets. According to NASA specialists, there is some fine dust that makes the blue near the sun's part of the sky much more visible on Mars. Any diamond fans out there? Pack your bags, because there's a planet out there made of diamonds, and it's twice the size of Earth. They believe it's mostly covered in graphite and diamond. A spacesuit costs about $12 million, but a visit there would cover the expenses altogether, don't you think? And if you're not a fan of space explorations and prefer the comfort of our planet, here's some good news for you. We have more trees right here on Earth than there are stars in our galaxy, the Milky Way. We know there are about 3 trillion trees here on planet Earth, and between 100 and 400 billion stars in our galaxy.
Put on your shades because Mercury is a hotspot. From the surface of this planet, the sun looks 3 times bigger than it does from Earth, and the light is 11 times brighter. Mercury may spin slower than Earth, but it still knows how to have a good time. One day on this planet lasts a whopping 59 Earth days. But don't worry. A year on Mercury is only 88 Earth days long, so if you want to feel like a centenarian, just divide your age by 0.25 or multiply it by 4. This way, you'll get your approximate Mercurian age. Easy peasy. And let's not forget about Mercury's funky orbit. For every 2 orbits around the sun, it spins twice. That means each hemisphere gets a full year of daylight followed by a long night. Time zones would be a mess on this planet, so we'll just stick to GMT. Ugh, did anyone forget to take out the trash? Why does it smell of rotten eggs in here? Sorry, it's because we're on Venus now, and these stinky clouds don't smell like roses. Any planet's day is basically just how long it takes for it to do a full spin on its axis. Well, Venus takes its sweet time with this, way slower than Earth, in fact. So a day on Venus lasts a whopping 243 Earth days, or almost 6,000 hours. Now here's where things get a bit tricky. Because Venus's day is so long, we actually use Earth's day as standard for keeping time on the planet. That means there's only one time zone for the whole planet. Seems convenient, huh? Venus's year is about 225 days. So if you were celebrating New Year's Eve on Earth in the year 2000, that would have been Venus's year 3251. So to keep track of time of Venus, we can use the local year, made up of 225 Earth days, but every 3 years or so, there's an extra short year made up of only 224 days. Not that confusing. We have leap years on Earth too, but it works a bit differently. We've made it to planet Earth. Woohoo! How many time zones do we have on this big blue ball? Give me a drum roll. 24. And did you know that we can actually mess with time a little bit? Yup, in about 80 countries, mostly in Europe and North America, we have something called daylight saving time. It's where we move our clocks forward an hour during the summer so we can soak up all that sweet, sweet sunshine. But beware, each country has its own rules about DST. So make sure you don't get caught snoozing when you're supposed to be working. And get this, some regions even have time zones that differ from UTC by half or quarter-hour increments. Can you imagine that the moon is getting its own time zone? The European Space Agency announced on Monday that it's time for the moon to have its own synchronized time zone. With more and more countries and private companies planning missions to our lunar neighbor, it's important that we all speak the same language when it comes to timekeeping. Right now, each mission carries Earth's coordinated universal time with it, which is fine when there are only a few missions happening at once. But with dozens of moon missions planned over the next few years, things are going to get tricky. We need a system in place to make sure everyone's on the same page, or we'll end up with different spacecraft out of sync with each other, and nobody wants that kind of chaos in space. Precise timekeeping is super important for communication and navigation, so we need to figure out a way to make sure everyone's on the same page. The ESA hasn't figured out exactly what form this new lunar time zone will take, but they're working on it. Should there be a single organization responsible for keeping lunar time? Or should we let the moon set its own time? And what about more granular time zones based on the sun's position? These are all important questions that need to be answered. When it comes to a day on Mars, it's not too different from a day on Earth. We're talking 24 hours, 39 minutes, and 35 seconds. A Martian year is 1.8 Earth years, which means the Earth year 2000 happened in Martian year 1063. Almost forgot. The Martian year has 668 local days. Phew! We sorted out the Martian calendar, but Mars will need local time zones. Because of its elongated orbit, the difference between summer and winter hours will be significant. Daylight saving time will be a thing on Mars. A year on Jupiter lasts almost 12 Earth years. Yeah, that's like a lifetime in dog years. But don't worry, they've got 12 seasons to keep things interesting, each almost as long as an Earth year. But a day on Jupiter only lasts 9 hours and 55 minutes. Also, since Jupiter doesn't have a solid surface, the clouds move at different speeds, so 2 free-floating atmospheric stations could experience different days. Hey, if we lived on Jupiter, we'd be in bad need of some cool app tracking all those things. Anyway, if we ever terraform Jupiter's region, most of the population will still live on Jupiter's moons, because the atmosphere is just too wild. And get this, the moon's revolution periods are connected, so we can use the same day counting system for all of them. On Io, we can have 2 standard Jovian days in one Earth day. How do we break that down? Well, We could have a minute of 53 seconds and an hour of 103 minutes. Or we could just stick with Earth's minute and hour and have a day that's 21 hours and 13 minutes long. How old are you? I'm 200 days old, and you? Sounds odd to you, Earth dweller, but dudes on Saturn count their age in days. A year on Saturn is crazy long, like more than 29 Earth years. Kiddos would only get a fraction of a year, while the oldest folks might get a whopping 3 years. So to keep track of time on Saturn, we could divide up a Saturnian year into 29 or 30 seasons. Oh, and fun fact, Saturn doesn't even have a solid surface, just rotating clouds that spin at different speeds. But we could still set up some cool research stations or helium extraction balloons to float around up there. One Uranian year lasts a whopping 84 Earth years. So, to make things easier, we'll stick to using Earth years for our calculations, and natural Uranian years can be used for special occasions, like reaching 1 Uranian year old. As Uranus doesn't have a solid surface, the rotation period is all over the place. Only science missions and helium mining companies are brave enough to venture into the atmosphere. And get this, each moon has its own day and date system. Pretty confusing. Most people won't ever celebrate 1 Neptunian year old. 1 year on Neptune is like that's way too long for us humans to stick around. But don't worry, we'll still bust out the confetti and party hats for special occasions, like when it's been 2 whole years since the first spaceship hit up Neptune. As for the rest of the time, we'll just use Earth years for all our business needs. Pluto takes a whopping 240 Earth years to orbit the Sun, which is way too long to use as a year in our everyday lives. A day on Pluto is almost like a week on Earth. So, to keep track of time, we're going to divide that into 6 standard Plutonian days, 3 of light and 3 of dark. That means a standard day on Pluto will last slightly more than 1 Earth day. Now, because Pluto's axis is super tilted, using time zones would be pointless. So we'll just use 1 time zone for the whole system. Easy peasy. As for the standard Plutonian year, it'll be almost the same as the Earth year, about 343 days. But once in 10 years, we'll throw in an extra day just for kicks. That's all for now. See you on Pluto.